Hello guys, welcome to my channel. Let us assume today we gonna start a new episode on revised simplex method, which is a useful method in the say, base or sense or of the operational research. It's a very useful method. We will solve this type of LPP or linear programming problem and using revised simplex method. In today's episode, we gonna discuss about the computational procedure of revised simplex method. So let's start. Before starting, if you are new in my channel, please subscribe the channel and press the bell icon. So the computational procedure, will start the computer step 1. What is step 1? Introduce the necessary slack or surplus variable. We have to first introduce the necessary and slack and surplus variable to convert the inequality constant into the equality constant. And if the problem is given in the minimization form, we have to convert it into the maximization form. So we all know that so convert a minimization problem, linear programming problem into the maximization problem, and we have to multiply the objective function by -1. Okay, and we have to derive the LPP into the standard form of the method, that is the revised simplex method, that is x is greater or equal to 0 and z is unrestricted. So this is the standard form for the revised simplex method. In this method, we will treat z, that is the objective function, as a variable, okay, of the problem. Okay, first we have to introduce some slack or surplus variable to convert the inequality constant into equality constant. Then the maximization problem, we will convert the minimization problem into the maximization problem, or then we will derive the standard form for the method. Okay, now step 2. Step 2, begin with the initial basis B, capital B is equal to Im, that is the identity, capital B is equal to the identity matrix of order M what is m? M is the number of constraint. M is the number of constraint. And from the auxiliary matrix B cap is equal to 0, sorry, it is B cap is equal to capital B minus CB 0 1. This is not 0, it is 0 matrix. This is 0 matrix. B cap inverse is equal to B inverse CBC inverse 0 matrix and 1, and A cap is equal to A minus C, and B cap is small b cap is equal to B 0, and XB cap is equal to capital B cap inverse into small b cap. Okay, we will start from the initial basis. Capital B is equal to Im, and we will form the auxiliary matrix B cap is equal like this, and then from this we will form the B cap inverse, then A cap, small b cap, and XB cap like this. Now we will quickly move on to the step 3. Compute the net evolution, that is Z1 minus C1, Z2 minus C2 dot Zn minus Cn as the product, as the component of the product, as the component of the product C B inverse 1 A minus C. Okay, if all the Zj minus Cj are non-negative, then the current basis solution will be the optimal. Current basis solution gives the solution will be the optimal, basis feasible solution. Okay, if at least one of the Zj minus Cj is less than 0 or that is negative, if at least one Zj minus Cj is less than 0, then determine the most negative Zj minus Cj. If zk minus ck is the most negative then xk will be the new basis variable and then find yk cap is equal to yk minus yk zk minus ck, or we can write b cap inverse is equal to ak, or this b cap inverse is equal b cap inverse into ak cap. So go to the step 4. If there is a tie for the most negative, then resolve the tie by any standard method. Okay, we will resolve the tie by any standard method. Then xk will be the xk nothing. And standard method, and go to the step 4. Okay, so in step 3 we will compute the zj minus cj. If all zj minus cj is greater or equal to 0, then the problem we will stop the problem there, because the current basic solution will give the optimal feasible basic feasible solution, and if one of the zj minus cj is less than 0, then we have to find the most negative among them, and then if zk minus ck is the most negative, then xk will be the new basis entering basis variable in the next step, and we will find yk cap and move to the step 4. Or if there is a tie for finding the most negative net evolution, and we will resolve it by any standard method. Okay, and move to the step 4. So we will now move to step 4. If all yik is less than 0, then there exists lesser equal to 0, then there exists unbounded solution. If at least one yik is greater than 0, then find the minimum ratio. If the minimum ratio is corresponding to XBR, then XBR will be the outgoing variable. And XBR will be replaced by XK. Okay, so in this method we will check all the element of yk cap. If all the element of yk cap is lesser equal to 0, then we will say that there exists an unbounded solution. If at least one element of the yk cap is greater than 0, then we will find the minimum ratio, and if the minimum ratio is corresponding to a basis variable, that basis variable xbr, then the basic variable xbr will be the outgoing variable, and in the next table xbr will be replaced by xk. Okay, then we will move to the step 5. Write down the result obtained in step 2, 3, 4 in a table. This table is known as revised simplex table. Revised simplex table. We will form the table like this. Basis variable, values, basis variable value মানে xb গুলো, b cap inverse, yk cap, and this will be minimum ratio. Okay, now we will move on to the step 6. Step 6. Convert the key element YRK of YK cap into the unity and all other component into 0 by suitable elementary row operation same operations are to be applied into the current V cap inverse. This will change V cap inverse into a V cap inverse for the next table. So in step 6 we have to convert the key element, and that is the rth element of the yk cap into 1 and all other element of yk cap into 0 by using elementary row operation, and same row operations, elementary row operation will be applied on the B cap inverse. So we will get the new B cap inverse for the next iteration or next table. Now we will move to the step 7. Consider new B cap inverse obtaining in step 6 as B cap inverse and go to step 3. Repeat the procedure until the optimal basis feasible solution is obtained, or there is a clear indication of unbounded solution. So in step 6 we have to consider the new B cap inverse obtained in step 6 to that B cap inverse as a B cap inverse in step 7, and go to the step 3, and we will continue the procedure or until either we will get some optimal basic feasible solution, or there is an indication that there will be a unbounded solution. Thank you. If you have any question about this method, ask me in the comment section. Thank you.